again. Let's talk about exponential and logarithmic equations. Okay, so on this first example, you'll see that above it I've got a couple of little notes here. So if we have two bases that are set equal to each other and they've got exponents, well, if I have b to the x equals b to the y, well, the bases are the same, so the exponents must be equal to each other as well, since this is an equation after all. And also, if we have a equals b, and say for some reason we need to solve for an exponent or something of the sort, I can take the log of both sides. And as it turns out, you can also go backwards at this. If you have a log a equal to a log of b, then a and b must be equal to each other. So I can go either direction with both of these properties. Okay, so in example 1, I have 8 to the x equals 2 to the x plus 6. Well, right now I don't have something that looks like b to the x equals b to the y because my bases are not the same. However, this 8 I can change into something that has a base of 2 because 8 is the same thing as 2 cubed. So instead of having that 8 to the x, I'm going to have 2 cubed to the x. And I'll still have equals 2 to the x plus 6. When I have a power to a power, I multiply them. So I have 2 to the 3x equals 2 to the x plus 6. Okay, so if I have 2 to the 3x equals 2 to the x plus 6, well, the only way that these two things could be equal, since I've got bases equal to each other, is if the exponents are equal to each other. So I have 3x equals x plus 6. So if I subtract x from both sides, I'll get 2x equals 6, and divide by 2 on both sides, and we get x equals 3. Okay, on example B here, I've got 5 to the x minus 2 equals 200. Okay, well, 200 is not a power of 5, so I'm not going to rewrite 200 as 5 to the something. However, I can use the second property we mentioned up here. If we've got an equation a equal to b, then I can take the log of both sides. So I'm going to have the log of 5 to the x minus 2 equal to the log of 200. As we've already discussed, if I have a log with an exponent, I can take that exponent and move it to the front. So here I've got x minus 2 times log of 5 equals log of 200. And then if I divide both sides by the log of 5, I'll get x minus 2 equals the log of 200 over the log of 5. And then I'll just need to add 2 to both sides. So at that point, you would stop and type into your calculator log of 200 divided by log of 5, and then you would want to add 2, and you'll get about 5.292. Alright, so here's an interesting problem. You can choose a prize of either a $20,000 car or 1 penny on the first day, double that to 2 cents on the second day, and so on for a month. On what day would you receive more than the value of the car? Okay, so this is a very serious decision that we have to make. We'll either have car, and watch out, these really good drawing skills here. Okay. Okay, sorry if I wasted your time drawing a car there. Okay, so you have either a car or you'll get a penny on the first day, or you can have 2 on the second day, or you could have, let's see, 4, and then the next day you'd have 8, and so on. So you're trying to figure out which one is more of a reward, the $20,000 car or this weird situation getting a whole bunch of pennies. Okay, so we need to decide between the two of these things. Now, first of all, we have two different units here. We've got dollars and we've got cents. So we'd want to change this $20,000 into pennies. So you go to the bank and you say, I don't want $20,000, I want $20,000 worth of pennies. Well, I would just need to move that decimal place over 2 times, and the bank teller would give you in return 2 million pennies. Okay, so let's look at this penny situation. So if on day 1 versus how many pennies you have. Okay. On day, let's say day number instead of day 1. Day number. Okay, so on day 1 you get 1 penny. On day 2 you get 2. And then on day 3, double that 2, you get 4. On day 4, double the 4, you get 8. And so on. Okay, and notice that we will have, on day 1 I get 1 penny, day 2 I get 2, 3 I get 4. I can also write this as 2 to the 0, and 2 to the 0 equals 1. And 2 to the first power will give me that 2. And 2 squared gives me the 4, and 2 cubed gives me the 8. So if I'm comparing the day number to my exponent, what's the pattern here? Compare the 1 to the 0, 2, 1, 3, 2, 4, 3. Well, if I'm on day n, that means I'll have 2 to the n minus 1, as each time my exponent was 1 less than the day number. So what I'm looking for is when, on what day, because if I know when this amount is greater than the value of the car, then I can figure out on what day that is. So I'm trying to figure out on what day will the amount of money that I get be greater than the number of pennies that I've got that are equal to the worth of my car. Perhaps it'd be a little more efficient, instead of writing 2 million each time, is if we changed this to 2 to the 2 times 10 to the 6. So let's use that scientific notation there. So we're looking for when is 2 to the n minus 1 greater than 2 times 10 to the 6th. Okay, so what I'm going to do here is go ahead and take the log of both sides. So I'm going to have log of 2 to the n minus 1 is greater than log of 2 times 10 to the 6th. Now in this first part here, I've got an exponent behind this log, so I can move that to the front. So I'll have n minus 1 times log of 2. And then on the right hand side, I've got multiplication, so I can split that into 2 logs being added. So I'll have log of 2 plus log of 10 to the 6th. Well, again, there I've got that exponent, so I can move that to the front, or if you catch it, I have log of 10 here, that's a base 10, so that part would cancel. This is just equal to 6. So this right hand side, I've got log plus 2 plus 6. Move the page down a bit there. Okay, so I've got n minus 1 times log of 2 greater than log of 2 plus 6. I'm trying to get that n by itself, so I'm going to divide both sides by the log of 2. So that goes away. So on the left hand side I have n minus 1 greater than. I don't want to just cancel these things out, because don't forget that the plus 6 is also being divided by log of 2. So the whole thing I need to figure out is log of 2 plus 6 divided by log of 2. Then you could take that part right there and plug it into the calculator, and you'll get 20.93. And then whenever we add 1 to both sides, we'll get about 21.93. So at the beginning of day 22, you will have more pennies than the worth of the car. So if you were given the option, do you want the car or do you want the pennies? Take the pennies in this situation, because that's only on day 22 will you have more than $20,000, and you still have the rest of the month to go. Okay, let's move on to the next example. Okay, so let's solve log base 3 of x minus 5 equal to 2. I mentioned before that if you have log of b of x equal to log of b of y, then x must equal y. Because if the rest of it is identical, then the x and the y must be equal to each other. So we can use that property a little bit here. Let me show you how we'll get to that using these two examples. Okay, first one. I've got log base 3 of x minus 5 equals 2. Really, you've got two choices here. Well, you've got several choices, and I've said that a bunch of times. With algebra, you can solve things different ways. Let me show you two different ways here. First of all, this is a little different, so just go with it. See this base of 3? Just like I could take the log of both sides, I can also make these things exponents on both sides. So I'm going to do this. I'm going to make each of these values an exponent. Log base 3 of x minus 5 equal to 3 squared. So notice that if you cover up the 3's, that's still the same equation that we started with, but we're going backwards from what we did before. And we've already talked about if you have 3 to log base 3, that thing will essentially cancel out, and you'll just be left with the x minus 5. And here we have 3 squared, which is 9, and when you add 5 to both sides, you'll get 14. That's one way of doing this. You could also, going back to the equation that we've got here, you could do the little log roll thing, and if we've got to rewrite this, I want to rewrite it as an exponent is what I'm saying. So I'm going to take 3 to the second power equals x minus 5. So 3 squared equals x minus 5. 3 squared is 9, and you get x minus 5, and add 5 again, you get 14. So you can choose to do that either way. Up to you, I don't mind. Part B, I have log 45 of x, or log of 45 times x minus log of 3 equal to 1. Remember, if we are subtracting logs of like bases, we can combine them by dividing. So this is log of 45x over 3 equal to 1. And 45 over 3, that simplifies to 15, or reduces to 15. So this is log of 15x equal to 1. Okay, so again, you could do like we did before. You could make these both an exponent, where my base would just match whatever the base of the log is. So you could raise each of these to the, so I could have 10 to the power of log base 10, and I would get 15x equal to 10 to the first is 10, and then divide both sides by 15. So 10 over 15 is 2/3. Or, going back to the other method of doing things, I could go right into rewriting this as an exponent. So if my base is 10, 10 to the first power equals 15x, and right away you can divide by 15, so you'll get 2/3 equals x. Either way, up to you. Let's look at these last two examples before I let you go. I have log base 4 of x squared equals 7. I'm going to go ahead and take that exponent of 2 and move it to the front. So I have 2 of log base 4 of x equals 7. And I'm going to divide by 2 before I do anything else, so that way I don't have anything sitting in front of the log. So I've got log base 4 of x equals 7 halves. And if I write this as an exponential expression, I would have 4 to the 7 halves equals x, and 4 to the 7 halves is equal to 128. And last one, log of x plus log of x plus 9 equals 1. So, different choices here. I've got addition of logs, so I could combine them by multiplying. I could raise them to the whichever power matches my base. Really, it's, you have choices here. I'm going to start out by multiplying these together. So I have log of x times x plus 9 is x squared plus 9x. And then I'm going to rewrite it as an exponent. So 10 to the first power equals x squared plus 9x. And subtract 10, so I'll get 0 equals x squared plus 9x minus 10. Does this thing factor? Well, it most certainly does. And it factors into x plus 10 and x minus 1. So here I get solutions of x equal to negative 10 and x equal to positive 1. Now there's something important that you need to do here. And really you should be doing this all along, but it's especially important because this scenario is why you must check your answers. Remember, we've talked about if you have log of any negative number, that is not okay. That would be considered undefined and would not work. So if you get solutions that when you plug them back into the function and they give you a log of a negative number, we want to disregard that and consider it an extraneous solution. And so we would have, looking at this negative 10, if I plug that back into what we started with, we'd have log of negative 10, not okay. But if we have a 1, everything would stay positive and happy, and that would be our only answer. Okay, that's it, and I'm glad you made it through the end of the video, and I will see you later. Bye.